everyone. Welcome back to SAT Math Question of the Day, where the Brothers Chaiken try to give you approaches, offer approaches on one, how to study for the Math SAT, and also how approaches on specific SAT math questions. We have Seth Chaiken, a PhD in math, and he is now a professor emeritus at SUNY State University in New York and Albany. I'm Joel. I have a PhD in mechanical engineering. Okay. One wonderful approach to studying for the Math SAT is to go to the Khan Academy website. Just do Khan Academy SAT practice, and you could take a course on the non-digital SAT or the digital SAT. I've been saying up till now that people in the United States will be taking the digital SAT starting in the winter of 2024, but that may not be correct. It looks like it's complicated. Who takes it and who doesn't take it? So, strongly advise, talk to your guidance counselor. In any case, we're going to be going through the digital side because the digital side problems sort of seem to be a little harder and a little bit more conceptual than the non-digital problems. So we're just going to be going through these advanced questions for a while. We do one question a day with the presumption that if we go over the approaches and answer the advanced questions, you would do the mediums and foundation questions yourself, and you should definitely go ahead and do those questions, and you should practice and do as many questions as you humanly can. The last time we met, today's also Throwback Thursday, which means we are going to do a question from a test from like 20 years ago, and you'll see back then that the questions had a somewhat more reasoning flair to them. Okay, I think we did exponential graphs the other day, but it also included transformations functions. Okay, polynomial and other nonlinear graphs. Cubics and quartics, they cross the axis multiple times at their zeros, where they cross the x-axis multiple times at their zeros. Wouldn't be surprised if that's the main concept.
Well, they might not have any zeros.
They may not have any zeros, right? Yeah, exactly. But you can see here that this question is related to the big concept that we just said. Okay, please read it. Pause, try it yourself. Pause it, come back, and you'll see how we approach it. Or offer a different approach. Polynomial h is defined as this thing, where c is a constant. If 2x minus 3 is a factor of the polynomial, then what is c? Whoa, so this is not a question that, at first blush, it doesn't appear to be a question that you can answer in a second, but there may be a trick to it. They're basically saying that 2x minus 3... it's a factor of a polynomial. Oh, I see. So, right. Aren't they basically, aren't you using the remainder theorem here or something? Yeah. If 2x minus 3 is a factor of the polynomial, then 2x minus 3 equals 0. X is equal to 3 halves is a root to the equation. So, if x equals 3 halves a root to the equation, that means that 2x cubed minus 9x squared plus cx minus 6 equals 0 when x is 3 halves. And that gives you one equation, one unknown. You're solving for c. This is a 2. So, we've reduced the problem to the holy grail. Best thing we can have in algebra, one equation, one unknown. You throw x in here, and you solve for c. I mean, that seems like a long way of doing it. Here you certainly have to understand that if x2x minus 3 is a factor of the polynomial, then x equals 3 halves is a root. And a root to a polynomial means, that's maybe something you'll have to correct this, is that a definition of a root? The root of a polynomial means that when you throw the x into the polynomial, you get 0. So.
Agreed, yeah.
Yeah, do you see any other? I bet there's
that's one approach, and I think this is the best approach.
Yeah,
However,
really? Okay.
There's another approach.
Yeah.
You use polynomial division.
Yes.
To divide the polynomial by, right. You'll need space.
You're right.
By 2x minus 3, and find out what you get. Find the remainder and the remainder should depend on C, and then pick the C that makes the remainder 0.
But there's something called synthetic division,
Yes.
which is a fast way of doing polynomial long division. So you can now. Nobody likes to do that. Nobody likes to do that. Well, we can try it. Then there's
I wouldn't call it synthetic division.
No, there's a new term
it's
called synthetic division.
I know. Yeah.
Yeah, synthetic division. Synthetic division, don't you do like 3 halves and then you go like this? And then you go 2, -9, C, and -6.
Yeah.
And then then you call it synthetic division, and then you get an equation for C at the end. This is going to lead to some sort of thing of C. L of C, just to give you a function of C, and you have to set that to 0, and that gives you one equation, 1 over C.
Yeah. I usually forget what the trick or the rule for synthetic division is.
Me too.
The point of synthetic division is that you could do the calculations without writing x's and powers of x all over the place.
That's right.
I don't like to do it. I don't like to use synthetic division.
Synthetic division because
what I do is division.
Yeah.
With keeping the x's around.
Yeah.
Yeah. So I don't think we should call division where you keep the x's around. So you just do the division of the polynomials. We shouldn't call that synthetic division. Just call it division.
I'm not calling it synthetic division. This is synthetic division. And I have a problem remembering how to do it. Because it's a formula. It's a cookbook. It's called cookbook math. If you're using synthetic division, don't get me wrong. If you're using it and you're good at it, go for it. Because it's fast. It is fast. But Seth and I, we didn't grow up that way. We never learned synthetic division as kids. So it never stuck. And also, we don't like to memorize cookbook math. So we have a problem with synthetic division. So, I wonder which way is faster. Should we, how about one of us does, now, by the way, it drives people crazy sometimes when, some people don't like when, we don't actually give the answer. We just give how to do it. So, of course, it's nice. A good approach at math, really, is to lay out how to do it. And don't be in a rush to get the final answer. The reason why is because this way you can review and see if you think you're doing it right. If you go a little bit too fast, you may not be able to check it as well. So, Seth, should we do this? How about you take one method and I take another and we see who gets the answer faster? So,
which one do you want to do?
I don't know. I have no idea. You choose, Seth. But choose quickly.
Okay, well.
Choose quickly.
So I don't have a coin.
Oh, don't worry. Just choose one. I'll tell you what, I'll do, this was what I said, okay? I said do it this way, so you do
okay, I'll do the division. You do the division. I'll do the division, and you do the substitution.
Exactly. Okay, here we go.
Ready, set, go.
Go.
And let's be silent when we do it.
Of course. You got C to be 12?
Yeah.
Seth, you got C to be 12. I got C to be 13. So I'm probably wrong. Oh, that's not good.
Uh-oh.
Yeah, I got 13. So, well,
I got an idea.
It took you longer.
Use the calculator.
Well, we could graph it.
Yeah.
Should we do Desmos to graph it?
Well,
and see where the zero is? We make C be 12, we make C be 13, and we see which one has the root at 3/2.
Yeah.
Should we do that? Okay.
Well, well, why not?
Yeah.
Why not, just take a guess. Take C equals 12 and then evaluate, type in the polynomial with the 12 and evaluate it at 3/2 and see if it's 0.
Wait, how are you planning on evaluating it?
You type it in.
Where? In a calculator?
Yeah. 3. Yeah, no, it's a calculus. Yeah, well, use a calculator to, type. It'll be a pain to type it in. Yeah.
No, I mean, people are going to have Desmos on their test. So why don't we just go to Desmos? Oh. Yeah, we'll just have to. It'll be so we need to see it. So here we go. 2x. No. Yeah, 2x cubed. Okay. Minus 9x squared.
Oh.
Okay, we'll do plus 12x, okay? Plus 12x minus 6. Okay, the 0 is at not 2. What? Wait. 2x cubed minus plus 12x.
Oh, no, I made a mistake. I discovered my mistake.
Oh.
You're right. You got it right. 13. Yeah, I discovered my mistake.
Oh, yeah, there we go. Look at that. Yeah. Wow, that's really interesting. The difference between 12 and 13 makes the graph look so much different. Isn't that funky? Look at that. Look at the life. Life depends on just a little 12 versus a 13. Look at the whole different nature of the graph. Wow. Boy, look at that.
What's this matter of scale is?
Yeah. Anyway, so it does look like 13 is wait.
Yeah, I made an arithmetic mistake. I said minus 12, minus 27, and I wrote that as 36. It's really 39.
Yeah.
So
by the way,
39.
There's the root we care about. That's 1.5 right there, the one I circled. Yeah. So, unfortunately, on a real test, as opposed to the SAT, you would have to, particularly if you had a graphing calculator, you would have time to check it. And this would be a good way. What is this? This would be a good way to check it. But on the SAT, it's like, it's hard. It's going to be hard to have the time to check it.
Yeah.
This is a long problem. This is the type of problem
it is.
You want to have your time banked up on because you got to be really careful here. It's unusual that they're going to want you to do these many detailed calculations right here, right? Oh, use a thinner, right? Yeah, this stuff is pretty hairy, right?
Yeah.
But the thing is, though, you also have to really know the concept that what does it mean to be a factor? What does that tell you? And then how do you turn this into a one equation, one unknown problem where C is the unknown? These are the strategizing. That's a major approach in doing basically any problem in math. Strategizing.
Yeah.
How do you plan to do it before you start actually doing it? And that's why it's nice to go here, because this shows the strategy. See, it's explicit as opposed to start throwing the x equals 3/2 in it immediately. This really shows the strategy. think strategy. When you're doing practice problems, any problem, particularly when you're learning the stuff, think strategy. So that's awfully quiet. It's pretty scary.
Yeah.
And then Seth and I are not going to do synthetic division. I hate people who say, well, do it yourself as an exercise. Frankly, someone looking and knowing synthetic division can do it faster than us, but I can do it. I have all these books here, see? Like that one up there, which I always look at, and that tells me how to do synthetic division. It's just a cookbook recipe. So let's see how they do it. Okay. What did we say, 13?
Yeah.
13. Okay, let's check. Great, wow. And I hope that people understood, well, I don't want to say I hope that the way we checked it was we graphed the polynomial and made sure that 3/2 touched the x-axis. Okay. Oops, what did I... Wait. What is this? Is this the same problem? Wait. No, this is a different problem. So what is this?
That's a different problem.
Yeah, it was a different problem. I don't know what I hit. I must have hit next. Ooh. Solving. Where are we? Oh, yeah, we're further down. I hope we get the same problem. You know, we may not. We may not get the same problem. We may have lost it. Yeah, we lost it. We can't see the answer. We can't go back.
Huh.
Oh, well.
Well, what if you try using the back button of the browser?
Okay, let's try that. Good idea, Seth. No.
A few times.
No.
Oh, no,
that
okay.
just totally loses it. Yeah, I'm sorry, everyone. We did this once.
Very, very annoying. I hate these. You don't have to see that anymore. You finished that problem.
I know that's completely not a great way to do education. You should have access to all of the stuff you did. That's why an actual book is good. So anyway, I guess we don't have a choice. But let's see. They would have been interesting to see how they did it. Would have been
I'd like to see how they did it. Too bad.
Yeah, I don't think we can go back. That's really, really frustrating. Oh, here it is. Oh, wow, this is the last one in algebra. Just can't believe it. Go back, come on. No. I believe in the... Oh, wait, what is that? No.
It's a different problem.
That's not wasting everyone else's time. Okay, so here's the Throwback Thursday question. This question comes from an SAT official book from, I don't know, years ago, 25 years ago. Okay, here we go. Unfortunately, I looked at it. Please look at it, try it yourself if you want, and then come back. And unfortunately, I actually looked at it, and I can offer some approaches. I have a big approach idea on this one because I sort of learned from my mistake. Anyway, for which of the following ordered passes is true? So when I first looked at it, I started looking at it algebraically, and I was saying, well, how do I do this? But can I do something which is really, actually, frankly, really stupid? But it certainly occurred to me. Can I do t minus s is less than or equal to... No, forget it. I mean, I was going to do a negative sign. I wanted to get like a plus b is greater than c, and e plus f is greater than d. So then could this help? Because these will cancel. Oh, so stupid. And then I realized, this is just... Then I stopped. Now, this is the approach I wanted to mention. I stopped. And I said to myself, okay,
you just answer the question.
I said to myself, well, I also said there's brute force. You could literally try each one, which would take too long. Then I said to myself, then I said to myself, the key thing, what type of problem is this? I stood back and I said, what type of problem is this? And I said to myself, equations.
It's a trivial problem.
I said 2 equations, 2 unknowns,
2 inequalities.
Yes, a system of 2 inequalities with 2 variables. And how do you generally do those? You generally do those by graphing and seeing, let's say this is the first thing, right? And this is the second thing. So the answer's here. So when I said that, I said, oh, okay. And I can probably go ahead and graph it roughly and probably get close to some of the answers, then try it. The key thing is when it's not obvious how to do a problem, step back and say, what type of problem is this? Notice they didn't use X and Y. What type of problem is this? This is a system of linear inequalities, which is generally solved.
It's the type of problem in which it's very easy to just answer the question.
Yeah, come to think of
it. You look at it. The first condition is that the two numbers are added together are greater than 2.
Wait. This is correct.
So A is a possibility, B is a possibility, C is a possibility. 3/2 plus a half equals 2, not greater than 2, and clearly 3 is greater than 2. So now among these, you just have to find a pair in which, when you subtract the second number, you get a very, very negative value. And this is the obvious one. Frankly, when I approached it, I took I took a little extra time to check if S minus T is less than -3 on all of them, and I quickly saw, 3 minus 2 is positive. It's not that. 2 minus 3 is -1, which is less negative than -3. Then I came to 1/8. Well, 1 minus 8 is really, really negative. It's -7. There's only one answer on the SAT that is correct, so you could stop there. And then 0 minus 3. 0 minus 3 is exactly equal to -3, so it does not satisfy strictly less than -3. So the practical way to solve this problem is brute force. What helps is to notice that checking the first condition is really easy.
Right. Yes. Seth, this is why Seth, I think, did better on his SAT than I did. Because I was bringing out the full guns when all you really had to do was just like step on the ant with your finger or something. Just go like this to the problem, as opposed to bringing out the full artillery that would use to do a more complicated problem. That's what sort of approach. Look and see if this is a simple way to do it. It's tough because sometimes it takes more time to figure out if this is a simple way to do it than it does to take the longer ways. But Seth's absolutely right. By far the best. So there's a pattern here. We're always looking for patterns. The pattern here is that this one is easy. Right? That one is easy. For example, if you had the problem like 2x plus 3y is greater than 7, and 7x minus 4y is less than -2. These, depending on what the x and y are, it's hard to check, right? It's a bit harder to check, particularly if they made an x be -1 and a y be 3.
Okay. Now, with this particular question, this particular question is set up so that another approach turns out to be very efficient.
Wait, are you adding those 2 plus 3? Or multiplying?
Yes.
Then that 2 plus 3 is 5. He may be a PhD in math, but he can't add.
Oh, yeah.
Okay.
So.
T has to be greater
right.
T has
I
to
made
be
a mistake. Okay.
Yeah.
Well, a pretty standard approach, right, Joel?
Yeah.
Given two inequalities and two linear inequalities, in two unknowns, you could try to solve it by elimination. Elimination won't always succeed.
Yeah.
But you could try by combining the equations to eliminate one of the variables,
right,
and get an inequality on the other variable. And this problem succumbs to that.
So this doesn't really help you because t greater than 2.5 is true for 3 of the answers. And 2 of the 3 of the answers. By the way, notice there are 5 answers in this test. Not 5.
Okay, yeah, so
that doesn't really help.
Yeah, so that doesn't help. That doesn't help. Okay.
So that was something. Let's not prove it. Whatever you do, don't prove it. But no. It's true that if A plus B is greater than C and E plus F is greater than D, you can say A plus B plus E plus the 2 plus F is greater than C plus D.
Yeah.
Okay, fine. Okay, let's not justify it. Let's just say okay. It's not usually.
But again, I think the intention of the test designer is to test whether you could detect that it's pretty efficient to simply verify the 2 conditions on the 5 choices keep doing it until you come upon one choice that verifies both.
Right. Yeah. And in this case, the pattern is that S plus D greater than 2 is incredibly easy to fix. Anyway, I can't.
Graphing it. Oh, well, you go down a rabbit hole.
No, let me try it.
Graphing it.
Let me try it. Okay, let me try it.
Well, it's not that graphing. The 2 lines are. One line is at a 45-degree slope. The other is a negative 45-degree slope.
Yeah. So let me try.
And you just have to find where they meet.
Yeah. Let me try it. First,
you'll find where they meet by treating the 2.
Okay, I'm going to try.
Make them into equalities to find out.
Okay, let me try it, Seth. Okay. Well, so this is y is greater than 2 minus x. So you go to 2, and it's a negative slope. Okay. Oh, and it's y greater than. So it's this way. Right?
Up there.
Okay, now, negative y is less than negative 3 minus x, which means that y has to be greater than x plus 3. Fine. There's 3, x plus 3, positive slope. So, and it's greater than. In this section here. Wow, look at that section there. Now let's look at the answers. 1/8 looks pretty good, but we know the answer. 3/2, no, I'm sorry. 3/2 is not going to cut it. 2/3, it's possible, right? 2/3 is possible, so you would check it, and then you'd realize it doesn't work. 1/8's cool. 1/2, are you kidding? 1/2, 3.5 is not going to work, and then 0. Ooh, see, 0/3 is right there, so it's on the line. But then you notice that there's what's called a strict inequality, so this one has to be tossed out. So, it takes a little longer. Seth's approach was by far the best. It's just that I was prejudiced against brute force and trying all the answers, but I didn't notice the pattern that this is incredibly easy to check. And this is also easy to check because it's wildly negative. Right? S minus D has to be less, seriously negative. Negative 3 is sort of a big number in this with respect to these things. So, it's possible this question could have been on the modern test. But you can see it has a little bit of a different flair. So I guess that's it for today. Today? Okay. Tomorrow I don't think we're going to meet, so we will be back on Monday. Talk to your guidance counselors about which test you believe you're going to take. And then just keep practicing on con. No matter which test you take, practice on con. And we feel that seems like the digital practice is a little bit more conceptual. Okay, everyone, have a great day. And of course, like us, dislike us, send us your comments put your comments on the YouTube videos. And if you have any SAT math questions, then email them to us at satmathquestionoftheday@gmail.com. Take care, everyone.